Good morning, students. If you can hear me, can you just put an yes? Yes, Sarmat Rajan, I can see your roll number, but you all know that you have to log in through that attendance in Indisol so that you can get your attendance. Yes. Tanvi, hello. Hello, Tanvi. Can you hear me, Tanvi? Just write in yes if you can hear me properly. Good afternoon, Biraj. Good morning, Sachina. Yes, ma'am. Okay, Gaurav has written yes. Good afternoon. It is 12:01, so good afternoon. Thank you, Biraj. Thank you for responding. Yes, hello to all of you. So we are going to start something new today. I'm waiting for your friends to join. Till now, 14 have joined only. So let's give them a couple of more minutes to join. Okay, I want to check whether we can see the PowerPoint. This has to go up. Please write an yes. Yes, if you can see the PowerPoint page clearly. It is being projected on the whiteboard behind me. So if you can see it clearly, just write an yes. Just write an yes. Okay, thank you. Thank you so much. And quickly send a message to all of the entire group. Send a message to the group to join immediately so that we can start our class. We don't want to delay anymore. Okay, so let me share the PPT. Now, the first thing that you see is statistics. The name of the subject that we are dealing with is managerial academics. That means all those subjects and the knowledge that you require to take managerial decisions. And out of them, statistics is one of the very, very important knowledge that you must have. Why are we doing this? Let our objectives be very clear. We are doing this so that you are equipped and geared to do your UWL classes. UWL is University of West London. You're going to start your course this year with UWL. And believe me, it's a must for all of you. Please do not think it's an option. It is a must for all of you. Why I'm explaining you? The reason is that UWL is giving you a degree, and it will not only help you to pursue further education if you want to. On the other hand, it will also equip you with a better educational degree, which is more widely accepted across your employers. So wherever you will go for work, you will be needing, means a degree is much more important than a diploma. This is point number one. Point number two, you all know that there is a crisis going around in the world due to this COVID-19 effect, and the hospitality sector has taken quite a toll. Though it's temporary, things will straighten out, I'm sure, by next year, but still you have to equip yourself with more certificates, more knowledge. You have to learn to multitask so that you are quickly acceptable by your employer, and you are the best choice for him. So please, all of you, it's a request from our side that you must do your UWL degree well, and for that reason, we are actually equipping you with certain extra knowledge that you will require to go do that course. Why I'm telling you? Because till now, whatever exams you have done, all those exams have been in such a way, structured in such a way that you knew the syllabus, knew the study materials, the teacher came into class, taught you the questions and answers, discussed the questions and answers, gave you a set of model answers. And what you did was you went back home and you studied those, rather, you marked them up before your exam and just produced it in exact words in your copies and got good marks. But please ask yourself, did you really learn? I'm sure you did not. I'll give you an example. I usually take accounts classes for the students of IIHN. So what we do, we go to the class, we show the format of the journal, you all copy it down. Then after doing the format, we give you a set of common journal entries. You also note it down, and you more or less learn it up or mug it up. And when you're given a sum on journal in your exam, using those very few examples that were discussed in class, just produce it just like you were taught in class. That's all. But actually, the concept of debit and credit is not still not clear in a lot of you. I'm sure about that because you have not learned to apply them in life. You have only learned to produce them in your copies, in your exam copies. You have not learned to actually apply that knowledge in day-to-day life, in your daily life. So here is where the difference of you at UWL comes. UWL will be testing you definitely, but their tests are not written examinations. Their tests are basically, they involve some assignments and projects which you need to do based on referencing and going searching on the net. You get a lot of material, a lot of research work. And to present that research work in proper tables, proper structure, and do an analysis on that research work, what will be required is the knowledge of statistics. Statistics is not a paper for you. Nobody is going to test you on statistics. You will not have a test on statistics. But you need to attend these classes and you need to know about this subject because you are going to apply these concepts when you will be solving those assignments and projects for your UWL course. So that is why it is very, very important for you. And believe me, I will keep this course very, very simple. Only those portions that will be needed for you for doing those projects and assignments, we will only do those portions. Statistics is a vast subject and it is quite difficult, but we will not go to that level. We will only do those portions which are relevant and will be required by you to present your assignments and projects of UWL. So that is why we are doing statistics. So don't get afraid. Don't think, because a lot of you, you have cousins and brothers and sisters, I'm sure, who are elder to you, and they, if you say, "Oh, I'm here studying statistics now," they will, "Oh my God, stats! Oh my God!" Right? So a lot of people are afraid of stats, but yes, some portions of stats are definitely difficult. But I can assure you, the portions that will be relevant for you are very, very easy, and I will try to break it down into as simple as possible. And this week's class is a class on YouTube for you, but from next week onwards, we will have a section-wise Zoom class. So when we have a section-wise Zoom class, it will be more interactive, and I can actually understand by looking at your faces whether you are following me or not. And you can also ask me questions. It's a excuse me, it is always better to have an interactive session, especially in these classes, so that you can ask your questions and stop me from progressing if you have any doubts. Okay, so we will take it slowly, we will take it in an interactive way, and I will definitely give you a lot of chance to get your doubts cleared. And also, when we start our Zoom classes, I will be sharing my phone number with you. Even in class, if you are not clear, or maybe you thought you have understood, but while after the class, while looking back and thinking back, what did ma'am say, you're not remembering, or you have some confusion, you can call me up anytime. I have no problem with that. All my students know that I am always ready to take your calls on a one-on-one basis, especially under this situation when we can't meet in person. When previously we could have met in college, you could have come and asked me or got your doubts clarified, but now it's not possible. So you are free to call me any point of time, And I always tell my students that if I am not picking your calls, what you will do, you will just send me a WhatsApp message. I am so and so from so and so year, so and so section. I will definitely call you back. Maybe I can be in a meeting, I can be in a class, I can be busy with something, and I just missed your call. If you don't write, it's an unknown number for me, obviously. If you don't write who you are, I cannot call you back. So please drop me a WhatsApp message in my number, introducing yourself, and I will definitely call you back. Okay? So let's start with statistics, introductions, and definitions. I'm again requesting you keep an open mind and think that like you learned in your KG, in your nurseries, 2 plus 2 equal to 4, like that I'll be taking you through the steps, don't worry. And I'm sure you will all, after my 6 weeks of classes with you that I have, I'm sure you're going to say, oh, stats is such an easy subject. Okay, I'm sure of it. So let's start. So, what is data? Statistics deals with data. Data is derived from the Latin word datum, and it is basically a statement accepted at face value. So anything we are saying. So if you are saying onions are priced at rupees 40, the weather is sunny outside, this student is the best student of the class, Anita has got 64 out of 100, all these are data. Everything is a data, right? It can be a data which can be measured in numbers, it can be expressed in figures or images, it can also be said in words. So data is anything which is given to you, and it can be numbers, words, images, etc. Now, before we get into statistics, let us understand there's a common misconception that data and information are the same thing. No, it is not. Data is the raw form. Information is the modified and classified and well-presented form of data. Quick example for you. You are all hotel management students. So when, suppose we go to the market and buy cucumbers, tomatoes, onions, and carrots, and we bring it back to home. And we have that. So those are our raw materials. Those are our data. Now we cut them up, decorate them or plate them properly, use some dressings and salt and other garnishings, and prepare a salad. That salad consists of what? The salad consists of those 4 vegetables only: onions, tomatoes, cucumbers, and carrots. But they are dressed properly and they are displayed and given to you properly in a plate, and that is your salad. So salad is my information. So data, when tabulated or made into tables or segregated, classified, analyzed, and then presented to you, data becomes information. So remember that all data is not information, but all information is data, because information is derived from data. Please understand this. So henceforward, if you hear anybody saying data means information, no. Data means whatever you hear, whatever you have with you, all the facts, right? But those facts, when presented in a proper style, more professionally, then that is called information. So statistics deals with numerical data. Data collected by observation, that is by counting or by measuring using a device. Nowadays, anywhere you go, what is being done, your temperature is being measured using a thermal, what is that called? A thermometer, but I forgot the name. Anyway, so by using that special machine, your temperature is being taken, and then only you are allowed to enter that place. So that measurement is being done by a device. But if I stand in a class and count how many students are there in the class, 1, 2, 3, 4, 5, 6, 7, 8, and like that, I have 60 students in the class, then that is I'm getting the data by counting. So that we can collect data either by counting or by measuring with any special device. Like the temperatures of throughout the day, if we keep a record, the highest temperature, the lowest temperature, what has been the temperature at every hour, we are talking about the weather. Then obviously that is also, I am using some device to record that. Statistics is a subject dealing with the collection, organization, presentation, analysis, and interpretation of data. So, what are the key terms? The first two terms that you need to know, acquaint yourself with, are population and sample. Population means the entire, consisting of all the people, right? If I'm talking about a class, when I talk about all the students, then all the students form my population. What is a sample? Sample is a selected few. So out of those, suppose I take one student from each row and I make a group of 10. So that is a sample. So if I do any study on that sample, then that is a sample study. If I do a study on all the 60 students of the class, then that's a population study. So remember, sample is a subset or is a part of the population. Now, statistics are of two types. The first one is descriptive statistics. The second one is inferential statistics. So, descriptive statistics deals with procedures used to organize, present, and characterize data in a convenient, usable, and communicable form. So, suppose I have all your marks in English. I have marks of 60 students of a class for English. So I write them up one after the other and write it down properly, draw a table. We all know, and believe me, we use a lot of Excel when we do these statistical tables and calculations and charts and graphs. We use Excel a lot. And I am going to teach you how to use Excel for your calculations and how to use Excel for drawing your figures and graphs and everything. We will be doing that in Zoom because I'll be sharing screen with you, and I will be doing it in an Excel file and showing it to you how you will be doing, because it saves a lot of time. It really saves a lot of time because you don't have to calculate a lot. Number two is the graphs are automatically drawn. If you just write the data in a proper table, select that table and click on the particular graph that you want, automatically the graph is generated. So you don't sit and draw the graph on a graph paper. Not anymore. We use Excel. So I will teach you how to do that in our Zoom classes. If not next week, the week after that, within 1 or 2 weeks, you will all be experts in using Excel for statistics. I can assure you that. I'll show it to you personally. So this descriptive statistics will include tabulation, diagrams, I told you, the graphs and the charts, calculating summary measures like percentages, average, measure of dispersion. These we'll all learn during the next few weeks. Summary measures for population are called population parameters. Summary measures for samples are called sample statistics. For example, when I find out the average marks of English for all the 60 students, then that is a population parameter. When I find out the average English marks for only the 10 students that I've selected, one from each row, this is a random selection, I take an average of their marks, then that's a sample statistics. Please understand this. Inferential statistics is basically something when based on a sample, you come to a conclusion for the entire class. Suppose the sample of 10 students, they have an English average of 55 marks. So we can assume that the entire class average will be more or less within that range. Maybe it can be 52, it can be 58, or it can be 60, but it will be more or less close to 55. So based on the sample, we are making an inference or a conclusion for the whole population. So that is called inferential statistics. And there, what is required? What do? We do estimation, we do hypothesis testing. Now, hypothesis testing is a bit of advanced statistics. You people do not have hypothesis testing. You don't need. So we will not do hypothesis testing, but we will do some estimations through something which is called time series. Time series again is very simple, very easy. I will teach you time series in one of the classes and you will see that it's a good method. So if we have figures, sales figures of the last year, monthly sales figures of the last year, based on that, we can estimate the future. We can predict the monthly sales for the next year. So we do that by a process which is called time series. I will teach you and show you how to do that. That estimation part we will do. But you people at your level or for your subjects or your analysis, your level of projects and assignments, you do not need hypothesis testing. So we will not get into that. It is a bit more complicated. So we are not going to do hypothesis testing. As I told you, we will only do those portions of statistics which will be relevant for you to do your projects and assignments. Variables and data. Now, variable is something that varies from one item or person to another. Means, for example, gender. You are all different in gender. Some are girls, some are boys. And age. Obviously, you also differ in age. Maybe by a day, maybe by a month, maybe by a year. But there is a difference in age. You all have your individual ages. And you have your individual opinions. It need not always be expressed in numbers. It can be something qualitative, like an opinion. So that is a variable. A variable generates data, right? How does it generate data? Each of you have a different age. So if you prepare a list of all your names and your corresponding ages, then that variable, you are generating the data or the list of the ages. There are different types of variable or data. Type of variable or data determines the type of chart or the graphical representation and analysis that we do. So types of data. What are the types of data? Let's quickly get into that. Looking at the chart, you see data can be divided into categorical and numerical, and categorical can further be divided into nominal and ordinal. Numerical can be divided into discrete and continuous. Now, what is each type? We will discuss in the next slide. Before that, let me tell you something that I have not yet shared the PPT with you, because I wanted first to discuss the things in class, explain the concepts in class, and then to share the PPT. Because if you would have got the PPT earlier, you may have got confused, or you may have got worried. Oh my God, such a big PPT. What is ma'am going to do? Oh my God, how do I learn this? So you might have had some confusions. So I purposely did not share the PPT with any of you. But as soon as this class is over today itself, all of you will get the PPT. I promise that. By the end of the day, this PPT will be sent to you. So you do not need to write down anything. You do not also need to take any screenshots. Okay? What you need is listen to me and try to understand what I'm saying, so that when you get the PPT, you can read it and you can recall what I said in class. That is important. You will get the PPT for sure. You need not worry about it. Now, let us see. Categorical data. Data grouped into named categories based on some non-numerical characters or trait. So data which is qualitative, like I told you, if we are making a list of your opinions, yes, no, very good. So if we are making a list of your opinions, or if I ask you, how was the class today? Student number 1 can say good, number 2 can say average, number 3 can say very good, number 4 can say excellent, number 5 can say not clear, number 7 can say boring. So there may be different opinions, but all these are not expressed in numbers. They are qualitative data. So qualitative data are basically called categorical data, and obviously they cannot be represented graphically except using bar and pie charts. Like out of 60 students, suppose, just for simplification I'm saying, out of 60 students, suppose 10 students said good, 20 students said average, and 30 students said very good. So we can draw a bar chart with the number of students saying good, with number of students, show the number of students using a bar saying average, and the number of students saying very good. So we can draw a bar chart or a pie chart, but nothing more than that. So no sophisticated analysis can be done if the data is expressed in qualitative form and not in numbers. This is categorical data. Next is nominal data. Items that are classified into unordered named categories. For example, they are mutually exclusive. Again, this is qualitative data. This is also not expressed in numbers, but there are two distinct categories, right? What are those categories? And these categories are mutually exclusive. If I say out of 60 students, 35 students understood what was taught in class, 25 students did not understand. So there are two categories, and those who did not understand cannot fall in the group of understanding. Those who understood cannot fall in the group of not understanding. So they are mutually exclusive groups. Another example, either somebody can be a smoker or he has to be a non-smoker. Somebody can own a car or may not own a car, right? So you cannot have, I may or may not have a car. It cannot be like that. It is either I have a car or I don't have a car. There's nothing in between, right? So these are mutually exclusive categories. Hair color, again, I'm talking about the hair color that you're born with. Nowadays, though, hair is all pink and blue and yellow and green and whatnot. But I'm not talking about that. I am talking about your original hair color. If you are born with black hair, you will not have a brown hair again unless you color it. If you are born with green hair, brown hair, you will not be having black hair, right? So remember, these are categorical. These are categorical, distinct classes, and they are mutually exclusive. Again, the analysis is lowest level, means little can be done with the data other than counts, graphs, and percentages, because again, this is not numerical data. This is qualitative data. Now comes the numerical part. If you go back to the classification, see, first categorical. Categorical has nominal and ordinal. This is what we have discussed. Now we are getting into numerical data. And numerical data will have two types. One is discrete, the other is continuous. Okay, so categorical data. Data grouped into named categories based on some non-numerical character. No, sorry, this we have already done. Ordinal. Okay, ordinal data and numerical data. Okay, just a minute. So, categorical, we have done nominal and ordinal. Now we are going into numerical. Numerical data, also called quantitative or hard data. Till now, we were discussing the non-numerical or non-quantitative data, right? Numerical data can be of two types, discrete data and continuous data. Again, the name suggests numerical means whatever the data, it is always expressed in numbers. Now, if these numbers are whole numbers, right, which we get usually by counting, for example, number of staff in a department, then they are called discrete data. It can only be expressed in whole numbers. You cannot have 5.5 staff. You will either have 5 staff or 6 staff, 5 employees or 6 employees. You cannot have 5.5 employees, right? You can have 60 students in a class. You can have 49 students in a class. You have 63 students in a class. You cannot have 49 and quarter students. You cannot have 52 and 3/4 students, right? It's not possible. So whenever something is expressed in whole numbers, again, not only for living things, for non-living things also, you cannot have 120 and half seats on a flight. It will be either 120 seats or 121 seats. You cannot have 84 and half seats on a bus. It will either be 84 seats or it will be 85 seats or somewhere less, but it has to be a whole number, please. So these data are called discrete data. What about continuous data? Continuous data means they are usually contained by measuring. So remember, discrete data is usually obtained by counting, and continuous data is got by measuring. Like I said, temperatures throughout the day, or maybe what else? Time taken to get to work, right? So whenever it is numerical data, whether it's discrete or continuous, you can use special methods for presentation and analysis, and you can use the highest level of analysis for this data, because these data are expressed in numbers. Very easy to do the analysis. Other types of data are cross-sectional data, that is data collected at a fixed point in a time. For example, number of employees on 1st January each year. So each year, 1st January, you are making a count of your employees. So that's categorical or cross-sectional data. Time series data, which I was talking to you about, if you remember in differential statistics, I told you time series. Time series data is a set of ordered data over successive time periods. Example, weekly sales or monthly sales for the past year. It helps us to do the estimates for the future year. So there's a quick activity. We'll go through it quickly. We are trying to just differentiate between nominal, ordinal, discrete or continuous data. Country of origin, you are either from India or USA or Dubai or wherever you are. So country of origin, again, it's a qualitative data. Number one, it's not a numeric data. So it has to be either nominal or ordinal. So it will be nominal data. Number of seats, it is expressed in numbers, but whole figures, not fraction or decimal. I told you this example, so it will be discrete. Customer attitude, again, it is a qualitative data which can be expressed, and it is ordinal because I told you they have customer attitude can either be good or bad or average, but it has to be mutually exclusive. So it is ordinal data. Length of the employment can be continuous because it can be expressed in fractions, it can be expressed in decimals. You can work for 3.5 years, you can work for 14 years, 6 months, you have 3 months, you can work for 14.23 years. So a lot of calculations can be done either expressed in percentage or expressed in decimals. So length of employment is continuous. Number of breaths is again discrete. It has to be whole numbers. Temperature, you can say it's continuous. I had given you this example also. Weight can be continuous. And salary can be continuous. It can be expressed in decimals or fractions, but we can take it as discrete also if it is given in for full numbers or whole numbers. Can be either means it can be either discrete or continuous, but we take it as continuous because it can sometimes be expressed in decimals and fractions. Okay. Now comes the tabulation of data. I will show you the different graphs that can be used for doing the analysis, different graphs that can be used for doing the analysis of data, right? Which you will be requiring while doing your projects and assignments. But before doing the graphs, you need to know how to express your data in tables. I told you the raw data is the unprocessed data. Those raw vegetables I gave you an example about. So that raw data is usually difficult to work with unless on a spreadsheet. Spreadsheet means your Excel sheet. So you need to construct a table called a distribution via tally diagram. How you do the tally diagram, and from raw data we prepare the tally. I'll show you in the next slide. It is given. From raw data you prepare the tally diagram, and from the tally diagram you prepare the frequency distribution in case of discrete data and group frequency distribution in case of continuous data. Again, just to remind you, discrete means whole numbers, continuous means numbers which can be expressed in decimal or fractions. So that is the difference. So we first do the tally diagram. From there, we prepare the table, either the frequency distribution or group frequency distribution. Let's see how. So tally diagram. Now, this is the data that we have taken from 36 people. You see that line on top, 21110210213421211100111 123000112133111. That is the data that we have collected from 36 people. And what was the question? The question was how many holidays they take per year. So person number one, out of those 36 people, number one said he takes 2 holidays. Number 2 said he takes 1 holiday. Number 3 again 1. Number 4 again 1. Number 5 again 1. Number 6 says I don't take any holidays at all. So the answer is 0. Number 7 again says, I take 2 holidays. So this goes on. But it is very difficult to understand from that single line. So what we do, so we check that line and see the lowest number and the highest number. Lowest number is 0, highest number is 4. So the minimum number of holidays taken by the people is 0. The maximum number of holidays taken by the people are 4. So we make a table and we make 2 columns. On the left we write holidays. Here we write holidays, and on the right we write tally. Tally means the tally marks. And we write the numbers that appear in our set of data 0, 1, 2, 3, 4 under holidays. So now what we do, every time we get 2, we will put a mark in the beside 2. Every time we get 1, we will put a mark beside 1. Every time we get 3, we will put a mark beside 3. Whenever we get 4, we will put a mark beside 4. When we get 0, we will put a mark beside 0. So the first one is 2. So we put a 1 beside 2. Again, then we have 1, put 1 mark. Then again 1, put the second mark beside 1. Then again 1, put the third mark beside 1. Again 1, put the fourth mark beside 1. 0, so put 1 mark beside 0. 2, then put 1 mark beside 2. This is the second mark beside 2. Then again we have 1. Now you have to remember when we are making these marks, first mark will be vertical, second mark will be vertical, third mark vertical, fourth mark vertical. The fifth mark we will cut across the previous 4. You see how it is given. 1, 2, 3, 4. Cut across means it's 5. 1, 2, 3, 4 are straight lines. Cut across means 5. Why this is done? Because then at a glance you can understand that is 5. For instance, in 1, you have a lot of people answering 1. So you don't have to count 1, 2, 3, 4, 5, 6. You don't have to count like that. We have 5 plus 5 plus 5. You can look at a glance and understand it's 5 because it is cut across. So 5 plus 5 plus 5 is 15, 16, 17, 18. So 18 people have answered 1. In 0, how many people have answered 0? 5 plus 2, 7 people have answered 0. In 2, how many people have answered 2? 4, 5 plus 1, 6 people have answered 2. In 3, for 3, we have only 4 people, and for 4, we have only 1 person whose answer was 4. So this is how you do a tally diagram. So you can quickly understand. Number of people who said 0 was 7. Number of people who said 1 was 18. Number of people who said 2 was 6. Number of people who said 3 was 4. And number of people who said 4 was 1. If we write it in figures, that becomes our frequency table. Frequency distribution. You see, we have just expressed the tally marks in numbers. The numbers that we got. That is the frequency. Means how many times the people go for holidays. How many times? When the question answers how many times, that means frequency of that thing. Okay, so 0, 1, 2, 3, 4 remains the same. Below that we write total, and frequency we will count the tally marks and write down the frequency in numbers. So it's 7, 18, 7, 18, 6, 4, 1, and the total is 36. Just adding up the frequencies. So total frequency is given in the last row, and this is used when there are small number of discrete data values. Discrete again means whole numbers. Nobody can go for a 3.5 holidays. It's either 3 holidays or 4 holidays, isn't it? Nobody can go for a half a holiday. So these are discrete data, means expressed in whole numbers. For that, we prepare this sort of a table. Group frequency distribution is used when large number of data values or data is continuous. Data is continuous means when data is expressed in fractions or decimals, or if the number of data, even if in whole numbers, there are huge number of data. So it is very difficult to give. This is the previous example that we used was only 0 to 4. Now, if it would have been 0 to 400, then imagine how many rows it would have had, right? And it's very difficult to count and go through it. It takes a lot of time. So we create classes. So if the data is 0 to 100, let's take an example 0 to 100. Then we will take groups. We divide it up into groups. So 0 to 9. 10 to 19, 20 to 29, 30 to 39, 40 to 49, 50 to 59, 60 to 69, 70 to 79, 80 to 89, and 90 to 99. If we make it like this, then we have groups, and then our word gets reduced. The number of rows, instead of making 100 rows, we are actually making 10 rows, right? We are taking groups and clubbing the data together there. Now, when we are doing this sort of groups, remember there are 2 things you need to remember. Number 1 is, not 2, actually 3 things. Number 1 is there has to be 6 to 10 classes. Means those groups that you are dividing, that has to be 6 to 10. Number 2 is the class intervals has to be same. If you are doing the first group with 10 people, 10 numbers, then the second group also has to have 10. Third group also has to have 10. Means if I'm doing 0 to 9, then the next one will be 10 to 19, not 10 to 15 or not 10 to 25. It has to be the same number of items in the group. So 0 to 9, 10 to 19, 20 to 29. So it is basically like that. Usually the width of the class is either 5 or 10. So we either take 0 to 5 and 6 to 10, or we take 0 to 9 and 10 to 19. It's like that. That we take the width has to be either 5 or 10. But there's no such rule for it, but that's the general practice. And most important point is, remember, there should not be any overlapping of numbers. You can see how I did the division. 0 to 9 and then 10 to 19. It is not 0 to 10, 10 to 20. Why we don't do 0 to 10, 10 to 20? Then if we have an answer of 10, where do we put it? In the first group or in the second group? We're not sure. If we have the group classes, if we have the classes like this, 0 to 10, 10 to 20, 20 to 30. Suppose somebody has given an answer of 10, then that 10 will be put in the first group of 0 to 10 or in the second group of 10 to 20. It is not clear. So that is why the classes have to be mutually exclusive. So if we are doing 0 to 9, then it will be 10 to 19, then 20 to 29, then 30 to 39, and so on. So there should not be any overlapping of classes. Very, very, very important point, and you must remember that. Example. So this is the age of customers in a fast food restaurant. See how many numbers are there. It's very difficult to create tally marks and all that with so many numbers. So what do? We find out the lowest number. I think the lowest number is 3. Let's check quickly. We can find out the lowest number. Lowest number. I think 6, 8, 6, whatever. Which is below 10. Lowest number is below 10, and the highest number is 65. So if that is the highest number, therefore we have to keep our groups from 0 to 70. We have to keep our groups from 0 to 70. The first group we will write is 0 to, we can write 0 to 9, or since this can be expressed in, it can be 9.75, because it can be expressed in fractions and decimals. It can be 9.5. It can be 9 years, 8 months. So because it's an age, so we will not write 0 to 9. We will write 0 but under 10, 10 but under 20, 20 but under 30, 30 but under 40, and so on up to 70, 60 but under 70. So 1, 2, 3, 4, 5, 6, 7 classes we make. And frequency, we just count how many numbers are between 0 and 0 but under 10. So let us see. First line has how many numbers? 1, 0, 6. So 1, 0, 8. 2 in the first line. In the second line, we have 0, 5. We have 0, 9, 0, 7, 0, 9. Okay, so 6 up till now. In the third line, we have 0, 5, 0, 9, 0, 4. In the fourth line, we have 0, 3, 0, 6. Okay, and in the last line we have 0, 8. So we have 12. So 0 but under 10, frequency is 12. This is how we will count and put down the frequency for all the, we'll check all the ages and put down the frequency. So how many are from 0 up to 10, are not up to 10, under 10, 0 but under 10. How many are from 10 but under 20? How many are from 20 to up to under 30? Then 30 to under 40, 40 to under 50, 50 to under 60, and 60 to under 70. We count and put those numbers. We can also do tally marks for this if you want. It's the same thing. And then you get the numbers and you do the total. We get the total is 80. Okay. This is how you do a frequency table. This is what is just written. I just now told you that the class intervals has to be equal, but it can be anything. It can be 0 but under 8, 8 but under 16. Need not be always 10 or 5, but usually that is the process that is followed. We either have the class intervals as 10 or 5. Now, let us look at this example. Again, these are prices paid for return transatlantic flights. Put this data into groups shown in your workbook. So, first thing we do is we find out the lowest number. What is the lowest number here? Let's see, the lowest number here is 155. So 155 is the lowest number, and the highest number I think is 625. Yeah, 625 is the highest number. So once you identify the lowest and the highest, then you can easily do those classifications. So we have done 100 to less than 200. 200 to less than 300, 300 to less than 400, 400 to less than 500, 500 to less than 600, 600 to less than 700. We have counted like we did the previous one. We have counted how many are there in each class, and just we have put the numbers of that is the frequency. We have added them up, and the total we have got is 25. So this is how the frequency table is done. Next, we can calculate the percentages and cumulative percentages from this table. Let's see how. So this was the age table that we had made, if you remember. The age table, 12, 27, 16, 12, 7, 4, 2, total was 80. This is the age table, 12, 27, 16, 12, 7, 4, 2, 80. This is the age and frequency. Now, how do we get the percent? Percent is very simple. You just do 12 by 80 into 100. The particular frequency of that class divided by the total frequency into 100. So frequency by total frequency into 100. So 12 by 80 gives you 15%. And so on. This is how we calculate. The last one is 2 by 80 into 100 gives you 2.5. 27 by 80 into 100 gives you 33.7. So this is how we do it. That is calculating the percentages. Next, we will be doing, and what is the interpretation? Why do we do this? Because we want to know what is the percentage of customers that were aged between 20 and 30. So age between 20 and 30, you can see the percentage is 20. So we can write 20% of the customers were aged between 20 and 30. Next, we find the cumulative frequency. Because why do we find this? So we know that from between 0 and 10, how many people are there? 12 people are there. Between 10 and 20, there are 27 people. So if somebody asks you how many people are below 20, then it's not only 12 or only 27. We have to sum up 12 plus 27, that is 39. 39 people are below 20. So that is why we find out the cumulative frequency. So just adding on the frequency of the last class. So first one is 12, then 12 plus 27 gives you 39. Then 39 plus 16 will give you 55. 55 plus 12 will give you 67. 67 plus 7 will give you 74. 74 plus 4 will give you 78. 78 plus 2 will give you 80. Obviously, the last cumulative frequency has to be equal to the total frequency. That is obvious. So we can easily say how many people are less than 50? You just look at the table and say 74 people are less than 50. How many people are less than 60? 78 people are less than 60. How many people are less than 40? 67 are less than 40. So this is your cumulative frequency. Now, if somebody asks you cumulative frequency percentage, then how do you do? It is, again, we find the calculation like this. It is cumulative frequency divided by the total frequency into 100. So it will be 12 by 80 into 100. For the second class, it will be 39 by 80 into 100. Then 55 by 80 into 100. Then 67 by 50 into 100. 74 by 80 into 100. 78 by 80 into 100. And finally 80 by 80 into 100. So this is how we get the results. So 15%, that's the cumulative percentage. 48.75, 68.75, 83.75, 92.5, 97.5. Obviously, the last one will be 100% because that's a cumulative percent that is equal to the total. Cumulative frequency is equal to the total frequency. Therefore, the percentage obviously has to be 100. The last figure always has to be 100. Again, what question does it answer? Let us see the question. 55 is the cumulative frequency and the percentage is 68.75. See, it's given in blue. So 55 or 68.75% of the customers were less than 30 years of age. 74 or 92.5 customers were below the age of 50. 78 or 97.5% of the customers were below the age 60. So this is how we interpret. We require this and we will use these cumulative frequencies when we draw a special graph which is called ogive. Ogive drawing also I will teach you in my subsequent classes. So these are the different tables. So what we have learned frequency, we have learned making the classes, we have learned cumulative frequency, we have learned cumulative frequency percentage. Okay, so these concepts we have learned. Now I will quickly show you, we don't have much time left, so I will quickly show you what are the different types of charts that can be drawn in statistics with the help of Excel. I'll just show you the charts today, the diagrams of the charts. The making of these charts we will cover in another class. I will use the Excel. I will share the screen with you, show you an Excel file, and teach you how to draw it. So the first is a pie chart. We all know what a pie chart. It looks like a pizza, all our favorite. And see the meal price and the number of people. So there are different meal prices, and frequency means the number of people buying those meals. So 20 people are buying rupees 10 meal, 80 people are buying rupees 15 meal, 200 people are buying rupees 220 meal, 120 people are buying rupees 25 meal, 40 people are buying rupees 30 meal, and 10 people are buying rupees 35 meal. So you just enter this table and use Excel, and you can create a chart like this, which shows you the different classes, how many people, the frequency of the different meal prices can be shown in a single graph like this. The same graph can be shown using a 3D effect. This is the 3D pie chart. Then we have bar chart, horizontal and vertical. The first one is a horizontal bar chart. Second one is a vertical bar chart. Horizontal bar chart, the x-axis will have your number of people, whereas y-axis will show you the amount of meal prices. This is opposite for a vertical chart. Vertical chart, the prices will be in the x-axis and the number of people will be in the y-axis. How to create? Don't worry, I will teach you each and every chart in Excel. 3D bar chart, the same thing with a 3D effect. 3D horizontal bar chart, 3D vertical bar chart. Then we have conical chart, which are shown in the form of cones. And we have something which is called a histogram. A histogram is the graphical representation of a group frequency distribution where rectangles are drawn between the class limits to represent the frequency. So when we are talking about the different classes, like, we identified the different classes 0 to 9, 10 to 19. If we are doing that and we are doing those bars without any gaps, then that is called the histogram, like this. So the x-axis will be showing the different classes and the frequency will be shown in the y-axis. So the age groups, you can see 0 to 9, 10 to 19, 20 to 29, and so on till 60 to 69. They are plotted in the x-axis. And the how many people are fall in those age groups, that frequency is shown in the y-axis. You can see there is no gap between the bars. So this is called a histogram. How to do an histogram, again, I am going to discuss and show you. It is very, very simple. It looks complicated, but it's very simple. I'll show it to you on Excel. Now, there is a typical, if you count, how many classes are there? 1, 2, 3, 4, 5, 6. There are 7 classes. So the middle class, which is the middle class? The middle of that. So for 3 on the left, 3 on the right. So the middle one is 30 to 39. 30 to 39 is the center of all the classes. 3 classes on the left, 3 classes on the right, and the middle class is 30 to 39. Now, if the frequency of that middle class is the highest, if we have the middle bar as the tallest bar, then that is called a symmetrical distribution. See, if the tallest rectangle is the rectangle in the center and the heights of the corresponding rectangles on either side are approximately equal, then that distribution is symmetrical. If the tallest rectangle, just know these names, you will not be requiring a lot y, and you will not be applying a lot of this in your work, but still you should be acquainted with the names. So if the middle bar of 30 to 39 is the highest bar with equal bars on the right hand side and the left hand side, then that's a symmetrical histogram. If the bar is towards the left, like this one, if the rectangle bar is near the lower end of the scale and there is a long tail to the right, you see it's in the lower end and there's a long tail to the right, then that is basically called a positively skewed distribution. And finally, the tallest rectangle, if it is in the upper end of the scale and there's a long tail to the left, if it would have been just the opposite, if the tail would have been in the class of maybe 50 to 59, and the curve would have been, the slant would have been like this instead of this. If the slant would have been like this, then that is called a negative distribution, negatively skewed distribution. So there are three shapes of the histogram. If it is more or less the middle bar is the tallest with equal tails on both sides, then that is a symmetrical distribution. If in the graph if in the lower classes is the tallest bar and we have a long tail, then that is a positively skewed distribution. And if the higher classes we have a long bar and the tail is in the front, towards the front, then that's called a negatively skewed distribution. Again, I'm telling you, you will not be using much of this, but you should just be acquainted with the terms symmetrical distribution, positively skewed distribution, and negatively skewed distribution. Why? When we proceed with our dispersion chapter, I'll tell you why we require these names. That's all. So that is all for today. I hope you've understood. I will quickly stop this PPT and I will go back to my live page. Just give me 1 minute. Okay. So, do you have any questions? You can write down in your chat box if you have any question. I can only see your attendances. Yes. I can see your numbers, roll numbers, everything I can see. Any questions, dears? If you have any questions, write down. If you don't have any questions, please write no questions in the chat box. I'm waiting for your response. If you have any question, please write in the chat box if you have any question. If you don't have any question, then please write no questions. I'm waiting for your responses. All of you. Last point, yes. Last point, as I told you, when we do the histogram, I'll explain that to you in more details. As of now, just remember the names. Symmetrical, positively skewed, and negatively skewed. When we do the histogram in Excel, I will show you why it is called and what is the effect of that. I'll show it to you when we do the Excel sheet. That is in the subsequent classes. Maybe next week or week after next, I'll be teaching you drawing these graphs through Excel. Okay? Sharmad Shazan, I will definitely clarify your point in that class. Don't worry. Anybody else? Any question? Any other person who has a question about anything? What we have done today is discuss the basic concepts of statistics. I am sure that it was quite clear. You will get your PPT by the end of the day. Once you get the PPT, all of you, please go through the PPT, go through all the points. Yes, that's what I'm saying. Ma'am, please could you send the PPT? All the numericals were not clearly visible. Yes, absolutely. You will get the PPT, dear. Don't worry. Don't worry, Ayushi will get the PPT by the end of day today. Don't worry. You will get it today itself. I'll ensure that. Okay, thank you. Thank you so much. Thank you for paying attention. Thank you for attending the class. And we will meet again section-wise on Zoom next week where you can ask me more questions and we can interact with each other. All the best. Have a wonderful weekend ahead and be happy. That's very important. Stay safe and be happy. Bye for now. Signing off.